Hello, welcome back to College Algebra. This is Unit 0, 0.2, Linear Functions and Equations. And today's lesson we're going to cover two common forms of a line. We're going to cover slope-intercept form and point-slope. Both of these forms of equations of lines build off of each other. And they require some very important information. Most importantly, they need at least a point and a slope. For slope-intercept form, it is y equals mx plus b, where m is your slope and b is your y-intercept. Now, we will talk about the definition of a y-intercept a little bit later on. But first, what we're going to do is we're going to identify what slope is. We covered that in the last lesson with average rate of change, and we know that slope is y2 minus y1 over x2 minus x1. Okay? And we use this form a lot of times when we want to graph a line. Okay? And it is the most standard form for a linear function. The other one is called point slope. And point slope is exactly what it says. In order for you to do this, you need at least a point and a slope. Okay? So this is used when you're given a point and the slope. Okay? So for exercise 1, we have a linear function, which is f of x. And f of x represents 3x plus 5. And that is a linear function in slope-intercept form. You notice that the slope is 3, that's our m, and our y-intercept is 5. But they want us to determine the y-intercept of this function by evaluating f of 0. Okay? Well, first of all, the y-intercept is the value of y when x is 0. Okay? So what that means is if you were to plug a 0 in for x, like we have in our function notation, we plug a 0 in for x, 3 times 0 plus 5. We know that 3 times 0 is 0 plus 5 gives us 5. So f of 0 is equal to 5. Now, when we write an intercept, we write it as a point. So when we write a point, we write 0, that's our x, and our y value is 5. Okay, so that is the y-intercept. That means that if we were to plot this point, on the line, it would cross the y-axis at 0, 5. Okay. Now the next thing is we're going to do a little bit of review because it's important because we need to know the y-intercept and the slope to be in order for us to use slope-intercept form. So average rate of change, just to cover like we did last lesson, is slope. And we know that slope is y2 minus y1 over x2 minus x1. Now in order to do this is on an interval. Our interval being -2 to 3. So we have to find the y values that go to each of these x values. So we're going to plug these x values in for the function. So we're going to do f of -2 by plugging a -2 in for x. So 3 times -2 plus 5. And when we simplify this, we get 3 times -2 is -6 plus 5 gives us -1. And if we do f of 3, we have 3 times 3 plus 5, which is 3 times 3 is 9, plus 5 is 14. So we have 2 points. So if we write this as 2 points, we have -2, -1. That's where we got from this. And then we have the point 3, 14. So to do slope, we're going to identify, this is our x1, this is our y1, this is our x2, this is our y2. And we're going to use slope form up here. So m is equal to y2 is 14 over x2 is 3 minus our y1 is -1 and our x1 is -2. And we have two negatives here. So two negatives equal a positive. So that gives us 15 over 2 negatives equal a positive. 3 plus 2 is 5. And then we just have to reduce. 15 over 5 is 3. Okay? So that is finding the slope. And if we were to put those together, we would get the equation of this line in slope-intercept form, the slope being 3 and the y-intercept being 5. Okay. So we'll go down to exercise 2. Exercise 2 says consider a line whose slope is 5 and which passes through the point -2, 8. So our slope, that's our m, and we have our first point. So I'm going to label it x1 and y1. Now, since we have a point and a slope, we're going to use point slope. And we're going to just plug it into that formula for it, which is nice and convenient here. So we have y minus y1. y1 is 8, is equal to our slope. Our slope we said was 5, is times x minus x1. Well, x1 was -2. And we know that 2 negatives equal a positive. So when we simplify this, we're just going to change those 2 negatives to a positive inside the parentheses. So 2 negatives equal +2. And that now is in slope. That now is in point slope. We're given our point, we're given our slope, and it's in point slope. Now in part B, they want us to put it in slope-intercept form. So what we're going to do is we're going to take our point slope, and we're just going to do a little bit of algebra to put it into slope-intercept form, which is y equals mx plus b. Okay? So to do that, we're going to first distribute. That means we're going to take this 5, we're going to multiply it into x, so we get 5x. We're going to take this 5 times this 2, we're going to get 10. And then we're going to rewrite what's on the left side. So this is y minus 8. And then we're going to get y by itself, just like it is for slope-intercept form. So we're going to do the opposite of subtracting 8. We're going to add 8. And so this is going to give us y equals 5x plus 18. So now we have it in slope-intercept form. And this right here was point slope. Okay. Now these are both the same equation of a line. One is more simplified than the other. Slope-intercept form is a lot simplified, whereas point slope is it's expanded out. Okay. So let's go to exercise 3. Exercise 3 says, which of the following represents an equation for the line that is parallel to y equals 3 over 2x minus 7. Now, key word here is parallel, okay? And it has to pass through the point 6, -8. So this is our x1, this is our y1. So what we're going to do is, if you look at our options here, it's an all-in point slope. So it's all in y minus y1 equals m times x minus x1. So what we're going to do is we're going to understand what parallel means. Parallel means that the line has the same slope. The two lines have the same slope. So same slope. And we know that parallel lines are lines that never intersect each other. And in order for that to happen, they have to have the same slope. Okay? So we know that our m here is going to be 3 over 2. We have our point, so we're just going to put it in point slope. So y minus y1. y1 is -8. Our m, which is our slope, is 3 over 2. 3 over 2. Okay? And then our x1 is 6, so minus 6. Now, the last step here is you'll notice that our answer is not really there yet because we have to simplify this. These two negatives equal a positive. So this is y plus 8 is equal to 3 over 2x times x minus 6. And so if we look here, the answer that we're going to circle is going to be number 3. Put that in this space here. So the answer is 3. Okay. So when you're given a multiple choice question, just make sure that you double check the correct answer because some of these look very, very similar if you look at them. It's just a difference of signs and switching the slopes. Okay, so now we go into this exercise 4 here. And this time we're given 2 points. So whenever we're given 2 points, that most likely means that we're gonna have to find the slope. Okay, so we're gonna find the slope first. Once we find the slope, we're gonna then put it in point slope form. And then once we put in point slope form, we're gonna put it in slope intercept form. So let's start with finding the slope. Now we know that slope is m equals y2 minus y1 over x2 minus x1. So I'm gonna identify my x1, my y1, my x2, my y2. So this is my x1, this is my y1, this is my x2, this is my y2. Now it doesn't matter which one you identify as your x1 or in your x2 and your y2. But what does matter is that if you say that this is x1, then this -2 has to be y1. Okay, so you can't say like, hey, this x1, this 5 is x1, and my y1 is 4. Okay, they have to be interconnected. They have to be connected to each other. Okay, so I'm going to just basically put in y2. So m is equal to y2 is 4 over my x2 is 20 minus my y1 is -2 and my x1 is 5. Okay, and so I'm just going to simplify. I know that 2 negatives equal a positive, so 4 plus 2 is 6. I know 20 minus 5 is 15. And then I'm going to reduce. I know that 3 goes into both 6 and 15, so this reduces to 2 over 5. And so this is our slope. Okay. Now, you'll notice that it said here simplest rational form. Rational means fraction. What they're saying is like put it and reduce it. That's what it means. Okay, so fraction is rational. B says write an equation on a line that is in point slope form. So we know that point slope is y minus y1 is equal to m times x minus x1. And so we're going to just plug in what we know. We know that y1 is -2. We know that our n, that's our slope, is 2 over 5. And our x1, we said was 5. And then we just got to just take those two negatives, make it positive. We know that 2 negatives equal positive. And then we're just going to leave it in point slope. And there's our answer. Okay. Box in our answer here. There it is. Okay. We go to C. C says, now they want us to put in slope intercept form. So we're going to take our point slope, which was y plus 2 equals 2 over 5x minus 5. And I'm going to then put in slope intercept form. That is y equals mx plus b. So to do that, I'm going to distribute. So 2 over 5 times x gives us 2 over 5x. 2 over 5 times -5 gives us -10 over 5. And then this y plus 2, we'll bring that down. And then we'll simplify this -10 over 5 we know is -2. So this is y plus 2 equals 2 over 5x minus 2. Okay. And then I'm going to do the opposite of adding 2. I'm going to subtract 2. So when I subtract 2, I'm going to combine it with the like term. This is a constant, so I'm going to have to combine it with this other -2. You do not combine it with the 2 over 5x because that 2 over 5x has a variable. They're not alike. They're not like terms. Okay, so I'm going to have a final answer of y equals 2 over 5x minus 4. And there's our answer. This is in slope-intercept form. Okay. Now, D says, for what x value will this line pass through the y value of 12? So they want us to know what is going to be our x value when the y value is 12. So we're going to use slope-intercept form because that has the parts, that has the x, that has the y. So I'm going to plug a 12 in for y. We don't know what x is, and then this is minus 4. So now what I'm going to do is I'm going to solve for x. I'm going to get x by itself. So I'm going to do the opposite of subtracting 4. I'm going to add 4 to both sides. And so this is going to give us 16 is equal to 2 over 5x. And here is here's the review part. We have to get rid of 2 over 5, okay, which is a fraction. So to do this, we're going to multiply both sides by the reciprocal. Now the reciprocal is basically this fraction flipping it upside down. So the reciprocal of 2 over 5 is going to be 5 over 2. And we're going to multiply both sides by 5 over 2. Now the reason we're doing this is because whatever we do to one side, we have to do the other. And by multiplying by the reciprocal on this right side, 2 times 5 is going to give you 10, and 5 times 2 is going to give you 10. And we know that 10 over 10 is equal to 1. Okay? And that's going to leave us with 1x. It's going to get x by itself. So if I take 5 times 16, that gives us 80 over 2 is equal to x. And 80 over 2 is 40. So x is equal to 40. Okay, there we go. So there we took 2 points and we wrote the equation of a line. That's all you need to have is 2 points in order to write the equation of a line. Now, in exercise 5, we're now given a graph. Now, students like this because it's a little more visual approach to being able to find the equation of a line. So we're going to put in slope-intercept form. We have to know what the slope is, and we have to know what the y-intercept is. So if we look, our slope, that's our m, is the change in y over the change in x. Or another way to look at that when we look at a graph is rise over run. Now, when we talk about rise, we're talking about if we were to read this from left to right, if we were to pick 2 points, rise means we're either going up or we're going down. Run means that we're going left or right. Okay, so I'm going to pick 2 points that are on this line. Doesn't matter which 2 points I pick, it's going to still give us the slope. But I'm going to pick these 2 points that are closest because we're less likely having to reduce if necessary. So I'm going to pick these 2 points. I'm going to rise up 1, 2. So I went up 2, positive 2, and then I went to the right 1. So I run to the right 1. That means I went to the positive 1 direction. And so 2 over 1 is just 2. So our slope is 2. Now the y-intercept is the value of y when x is 0. So when x is 0, what is the y value? Well, it's 1. So 0, 1. Or another way to identify this is, where is the line crossing the y-axis? At what point is it crossing the y-axis? Well, it's crossing at 0, 1, the y value being 1. So our b value is 1. So when we put our m and our b together, we get y equals 2x plus 1. There is the equation of the line in slope-intercept form. Now it says, what must be the slope of the perpendicular to the one shown? Now, perpendicular means that it's a line that intersects with the line that's given here to form a 90-degree angle. Okay? So perpendicular means forms 90-degree angle. Forms 90-degree angle. okay? In order for this to happen, the slopes have to be opposite reciprocals. So let's talk about what an opposite reciprocal is. An opposite reciprocal is taking our slope and flipping it, so changing the numerator and the denominator, and then changing the sign. So this is the opposite reciprocal slope. So if our slope was 2, we flip it, our slope would then be 1 over 2, and then opposite sign. So if this is positive 2, it becomes negative. And so this is the slope of the perpendicular line. It's negative 1/2. Then it says draw a line perpendicular to the line that's shown that passes through the point 1, 3. So what I'm going to do is I'm going to go over to 1, 3. So I'm going to go over 1 and then go up 1, 2, 3, and it's this point here. Okay? And then it says perpendicular. So we have to use a slope. We're going to, from this point, we're going to go down 1, and then we're going to run to the right 2. So 1, 2, and plot this point. And then we're going to draw our line that connects those 2 points. Okay. So I'm drawing my line that connects those 2 points. And I'm putting arrows on them. Okay? And that forms a 90-degree angle. So how we can identify 90-degree angles is we put these boxes here. And those identify the 90-degree angle. Okay? So there we go. We just found a line that made this perpendicular to the other line. They intersect to form a 90-degree angle. Now D says write the equation of the line you just drew in point slope form. So point slope is y minus y1 equals m times x minus x1. So we know our point. Our point was 1, 3. So x1, y1. And so we write y minus 3, because that's our y1. And our m is negative 1/2 x minus x1. Or x1 was 1. And there, it's in point slope. Okay. Now, part E says, does the line that you drew contain the point 30, negative 15? Now, it's going to be really hard to see that on the graph because our graph is so small. So we're going to do this with a little bit of algebra here. We know that 30 is our x1, or our x value. We could just say that this is our x value. And we know that negative 15 is our y value. So we're going to plug those values into point slope. And if the left side equals the right side, then it's a point that's on the line that we drew here. Okay? So we're going to plug in our y value, negative 15, into here. Then we're going to plug our x value of 30 into here. So this is negative 1/2 times 30 minus 1. And if you take negative 15 minus 3, you get negative 18. And if you take 30 minus 1, that's negative 1/2 times 29. This gives us negative 18 is equal to negative 29 over 2. And you could put that in your calculator. You can just do a little bit of long division here. Negative 18 is equal to negative 14.5. Well, negative 18 is not equal to negative 14.5. So we're going to say no, it does not. Okay, so it does not, it's not a point on that line we drew there. Okay, in order for it to be a point that's on that line that we drew, they would have to equal each other. The left and the right would have to equal each other. Okay, and so that is 0.2, equation of a line. Okay, we talked about slope-intercept form. We need, we could have a point, we have a point, we have a slope. We could have 2 points. We could have a graph with a line on it, and we can put in slope-intercept form. Point slope, all we need is a point and a slope. And we can use point slope to find slope-intercept form. It's just a more slope-intercept form is the standard form for the equation of a line. We use that to graph a line. Okay? And then we did some review over average rate of change. We need to be able to identify slope, most likely when we're given 2 points. Okay? So now what I would like you to do is make sure that you jot down any questions. Come back to me with any questions that you have. Complete the homework over 0.2. And I look forward to answering any of your questions. And I hope that you have a wonderful day. And I will see you soon. Have a wonderful day. Bye.